Oh, absolutely.
This architecture, it underpins almost every big SaaS product out there. Think CRM, infrastructure platforms, everything. But, it's still one of those concepts that's surprisingly misunderstood, isn't it?
It really is. It's everywhere, but people don't always grasp the implications. And understanding multi-tenancy, it directly hits your bottom line, your security posture, even the user experience you deliver.
Right.
So for this deep dive, our goal is pretty clear. Let's get past the jargon. We want to explore the standard models, really dissect what they mean for security, for performance, and help you understand how these design choices actually affect your organization day to day. It's about balancing those potential cost savings against, well, the sometimes massive operational complexity.
Okay, let's start right there with the basics. What is multi-tenancy?
At its heart, it's an architectural model. You have a single application, a single service, but it's serving multiple distinct groups of users. We call those groups tenants.
Tenants.
And the key thing, the real insight, is that these tenants share the underlying infrastructure. We're talking servers, the app code itself, maybe even the physical hardware.
But and this is the important part. Their data and their configurations have to stay separate, logically separate.
Exactly. That logical separation is crucial. The classic analogy, and it works pretty well, is the office building.
Ah, yes. The office building.
Think about it. All the companies renting space, the tenants, they all share these big, expensive resources, right? The elevators, the air conditioning, the security desk in the lobby, the main power feed.
That shared infrastructure. It's what makes renting a small office affordable compared to building your own skyscraper.
Precisely. It drives down the cost for everyone. But you've got Company A, maybe they're a law firm, and Company B is, I don't know, an online store.
Totally different businesses. Different customers, different products, different sensitive data.
Completely separate. Their operations are isolated, their data is isolated, even though they might be sharing the same floor, the same ventilation system. That's the core idea. Isolated data within a shared resource pool.
And in software, that isolation isn't walls and doors, it's software control.
Exactly. Software logic. Think about something like Salesforce. Thousands, probably tens of thousands of companies, many competing directly, all using the same core CRM application.
Yeah.
But because of really strong tenant-specific security controls built into the platform, Company A just cannot see Company B's sales deals. Not accidentally, not maliciously, it's architected against that.
Okay, so let's unpack that. If efficiency and cost are the big drivers, what does choosing this architecture really mean for businesses, either using these platforms or maybe building them? Let's hit the economics first. Why is multi-tenancy basically the default now for SaaS?
Scale and cost efficiency. It really boils down to that. With a multi-tenant setup, a provider can serve way more customers from the same chunk of infrastructure compared to dedicating resources to each one, like in a single-tenant model.
So you avoid shelling out for dedicated servers for every single customer.
Exactly. The capital investment is much lower. And because those infrastructure costs, servers, power, cooling, maintenance, are spread across maybe hundreds or thousands of tenants,
The operating cost per tenant plummets for the provider.
right. And usually, hopefully, they pass those savings on to you, the tenant, through lower subscription fees, lower upfront costs. It makes powerful software accessible.
Okay, here's the flip side. You hear shared infrastructure, and immediately security alarm bells start ringing, don't they? Am I putting my company's crown jewels at risk by basically sharing a digital apartment block with potentially hundreds of strangers?
That is the fundamental trade-off. It's the core tension. The potential risk, the thing everyone worries about, is cross-tenant data leakage.
Meaning my data somehow ends up visible to another tenant.
Yeah, either accidentally, maybe due to a bug, or, much rarer but possible, maliciously if someone finds an exploit. It's about bypassing those logical isolation walls we talked about.
Okay.
Now, platform providers pour enormous resources into preventing this. Data isolation failures are rare, but if it does happen to your company, it's catastrophic, which is why, regulated industries are often much more cautious about this.
So what are the weak points? Where do things typically go wrong that could allow leakage? What keeps engineers up at night?
A lot of it comes down to the application code itself. Things like forgetting to filter by the tenant ID in a database query. If the code just asks for all customers instead of all customers for this specific tenant.
Uh-oh. You could potentially pull back data belonging to someone else.
Exactly. It sounds simple, but in complex systems, it requires real discipline. You also worry about weaknesses in how data is partitioned in shared database tables, maybe misconfigured API gateways. If everyone's hitting the same API endpoint, you need rock-solid authorization there too.
So given that risk, how do the big platforms fight back? What are the standard defenses that make multi-tenancy generally safe?
Well, they rely on a set of pretty standard but powerful security controls. Things like strong authorization, role-based access control, RBAC defining who can do this.
Right, standard stuff.
But really critical in this context is something called row-level security, or RLS.
RLS.
Yeah.
Okay, let's make sure everyone's following. In simple terms, what's RLS doing?
Think of RLS as an automatic invisible filter applied by the database itself. Even if my application code for some reason messed up and asked for all the data in the invoices table, the RLS policy, which is tied to my user identity and my tenant ID, steps in at the database level and modifies the query on the fly. It essentially adds a where tenanted, my tenanted clause automatically.
So it's a safety net built into the database layer itself. Even if the application asks incorrectly, the database refuses to show data that isn't mine.
Precisely. It's a really powerful system-enforced guarantee on data access. Hugely important for multi-tenancy.
Okay, that makes sense. Security controls are vital. But let's shift gears to user experience, specifically performance. If the security is tight, the next big worry with shared resources is performance hits, right? The classic noisy neighbor problem.
Exactly, the noisy neighbor effect. We've all felt it. It's when one tenant starts doing something really resource-intensive. Maybe they're running a massive end-of-quarter report that hits the database hard.
Yeah, or uploading a gigantic file or running complex analytics.
Right. And suddenly they're hogging so much of the shared CPU or the disk bandwidth or memory that performance degrades for everyone else sharing that same physical hardware. Your app slows down because your neighbor's having a party.
We've definitely all been there. Your normally snappy financial app suddenly grinds to a halt right at month-end close. Probably because some huge enterprise tenant is doing a massive data crunch next door. So how do providers promise, reasonably stable performance in a shared world?
They use a bunch of sophisticated controls. Things like setting resource quotas. You simply can't use more than X amount of CPU per hour, or rate-limiting API calls.
We're putting caps on things.
Yeah, preventative measures. Plus dynamic resource allocation, shifting workloads around intelligently. But probably the biggest technique, especially for databases, is horizontal partitioning. You often hear it called sharding.
Sharding sounds very technical. Give us a visual.
It's basically just dividing up the tenants and their data across multiple separate sets of hardware. Instead of cramming all 1,000 tenants onto one massive server cluster, you might put tenants 100 on server A, 101, 200 on server B, and so on. These groups are called shards.
Okay.
Yeah.
So smaller apartment buildings instead of one giant one.
Exactly. Now, if tenant 55 starts running that monster report, they might impact the performance for tenants 1 through 100 on server A, but tenants 101 and onwards on the other servers, they won't even notice. It contains the blast radius of a noisy neighbor.
Right. Minimizes the impact. Okay. Let's connect this to the really big picture. Compliance. It often feels like regulations, not just tech preferences, end up dictating the tenancy model, doesn't it?
Oh, absolutely. Regulations are very often the #1 constraint. If you're in healthcare dealing with HIPAA, or finance under PCI DSS, or maybe government with FedRAMP, some of these regulations might have really strict data isolation requirements.
Like they might actually mandate physical separation of data.
Sometimes, yes. Certain rules might imply or explicitly state that specific types of sensitive data cannot physically reside on the same hardware as data from other organizations. And if that's the case, well, a fully shared multi-tenant model might just be off the table from the start.
But not all regulations are that strict.
No, definitely not. Others, like GDPR in Europe, for instance, often allow for logical separation, provided the provider can prove those controls we talked about: RLS, strong encryption, maybe tenant-specific encryption keys. Robust auditing are truly effective in protecting privacy.
It depends on the specific rules you're governed by. And if something does go wrong, a breach or a compliance failure, who's holding the bag? Where does the liability fall?
Generally, it's a shared responsibility model. The SaaS provider is responsible for the security of the cloud, maintaining the infrastructure, patching the servers, ensuring those isolation mechanisms work correctly.
Okay.
But the tenant, You're responsible for security in the cloud. That means choosing a service that actually meets your compliance needs, configuring it correctly, managing user access properly within your tenant space, and handling your data safely according to the rules.
Got it. Shared responsibility. Okay, this is a good point to actually lay out the main architectural models. You mentioned single tenant earlier. Let's walk through the spectrum from like total isolation down to fully shared.
Right, think of it as a scale of isolation. At one extreme, the highest level of separation, you have Model 1, single tenant.
The private mansion.
Exactly. Each customer gets their own completely dedicated infrastructure stack. This could be dedicated virtual machines on shared hardware, or for maximum security and performance, literally their own dedicated physical servers, network gear, databases. It's their own private instance of the application.
And the benefits are obvious, right? Peak performance, no noisy neighbors at all, and it meets even the strictest compliance demands for physical separation.
Absolutely. The downside, cost. It's by far the most expensive model because you're not sharing any infrastructure costs. You see this mainly in those highly regulated sectors, sensitive government work, core financial systems, where the absolute need for isolation trumps the cost factor.
Okay, so that's one end. What's the other end?
The other extreme is Model 2, the standard multi-tenant environment we've mostly been discussing.
The busy apartment building.
That's the one.
Yeah.
This is the most common model for SaaS by a long shot. All tenants share the same physical hardware, the same application code. Isolation happens purely through that software logic, the RLS, the tenant IDs, the application level controls.
Lowest cost, because the infrastructure expenses are spread so thin.
Precisely. And our Slack example fits right here. Or think about Microsoft 365. Millions of organizations sharing infrastructure, all separated by software.
Okay, so private mansion, busy apartment building. Is there something in between?
There is. Model 3. Hybrid models. This is where architects try to get clever and, find a balance.
As to both worlds, maybe?
That's the goal. In a hybrid model, you mix single-tenant and multi-tenant approaches for different parts of the same application.
How would that work in practice?
Well, maybe you decide your core customer database, the really sensitive stuff that falls under strict regulation, needs to be in a dedicated single-tenant database instance for maximum isolation.
Okay, protect the crown jewels.
Right. But maybe other parts of your application, like, say, the microservice that handles logging or maybe a basic analytics service, those are lower risk, less sensitive. So you run those components in a shared multi-tenant environment to save costs.
Ah, I see. So you get the targeted isolation where it matters most, but you still get cost savings on the less critical pieces. Sounds smart, but I'm guessing the catch is complexity.
Bingo. Huge increase in complexity. You now have to manage and orchestrate both types of environments, ensure they talk to each other securely, handle deployments across both. It requires a significantly more sophisticated engineering team and tooling. The operational overhead can jump dramatically.
Yeah, I can see that. Okay, this is fascinating. The nuances go even deeper, don't they?
Yeah.
You mentioned database patterns earlier. Even within that common multi-tenant model, there are different ways to actually design the database itself.
That's right. And these database design choices have really significant trade-offs in terms of security, cost, and again, that operational complexity. It's often where the rubber meets the road.
Okay, let's break them down. Pattern number one you hear about is shared database, shared schema.
This is often seen as the most pure multi-tenant database approach, or maybe the most resource efficient. Everybody shares not just the same database server, but the exact same set of tables within that database.
So one giant customers table, one giant orders table for everyone.
Exactly. And the only thing distinguishing tenant A's customers from tenant B's customers is that crucial tenanted column on every single row.
Maximum resource pooling.
Yeah.
But the vulnerability we talked about earlier seems massive here.
It is. The burden is entirely on the application code. Every single database query your application makes must include that where_tenanted.filter. If a developer forgets it, even in one obscure report.
You've got a data leak. You're relying 100% on perfect application code forever.
Correct. High efficiency, but high risk if not implemented flawlessly.
Okay, what's the next step up in isolation? Pattern 2.
Yeah.
Shared database, separate schema.
Right. So here, all tenants still share the same underlying database server or cluster, but each tenant gets their own schema. Think of a schema like a dedicated folder or namespace within the database. Tenant A has its own set of tables, tenanted.customers, tenanted.orders, and tenant B has its own, tenantb.customers, etc.
So the database structure provides some inherent separation, My queries for tenant A data literally can't even see tenant B's tables.
Exactly. It provides much better logical isolation at the database level. You've largely mitigated that risk of a missing tenanted filter causing a leak across tenants because the tables themselves are separate.
That sounds much safer, but
Phew.
I sense a but coming. What's the trade-off here?
Maintenance. Imagine you have 5,000 tenants. That means you have 5,000 separate customers tables, 5,000 orders tables. Now, what happens when you need to add a new column to the orders table for a new feature?
Oh, wow. You don't just update one table, you have to update 5,000 identical but separate tables.
Precisely. Running database schema migrations across potentially thousands of schemas becomes incredibly complex and risky. You need bulletproof automation, because if that migration script fails halfway through on tenant #2347, you're in a world of hurt.
Yeah, okay. That sounds like swapping one major risk for another. So what's the third option? Pattern 3, separate databases.
This offers the highest level of database isolation within a potentially multi-tenant application architecture. Each tenant gets their own completely separate database instance. Tenant A has DB tenant, tenant B has DB tenant B running independently.
Maximum isolation. Data is physically segmented at the database level. This sounds like the simplest way to meet strict compliance rules.
It often is. It makes proving isolation very straightforward.
Okay, let me jump in here. The operational overhead must be absolutely enormous, right? If I have thousands of customers, I don't just have thousands of schemas, I have thousands of databases to manage, patch, backup, monitor, manage connections for.
You've hit the nail on the head. The operational overhead is massive. You need very sophisticated automation for provisioning, managing credentials, handling connections, doing backups, applying patches across potentially thousands of database instances. The cost in terms of management complexity and potentially infrastructure can be very, very high.
So great isolation, but potentially crippling operational costs and complexity.
That's the trade-off.
Okay. Wow. So bring this all together. There are so many factors. How does someone listening, maybe evaluating a SaaS tool or designing their own product, actually choose the right model? What are the key takeaways?
You really need to weigh four main things systematically. Number one, as we've said, is regulatory compliance.
Non-negotiable sometimes.
Often, yeah. What do your specific industry regulations require regarding data isolation? Physical separation needed? Logical separation, okay. That might make the decision for you right there.
Okay, compliance first. Number 2.
Performance expectations. Especially if you're serving large enterprise clients. Do they have strict performance service level agreements, SLAs? Are they likely to be noisy neighbors themselves? If so, you need solid strategies to guarantee performance, which might push you towards single-tenant or at least very carefully managed sharded multi-tenant setups.
Makes sense. Number 3.
Operational overhead. Be brutally honest about your team's capabilities and resources. Can you actually manage the complexity of a hybrid model or thousands of separate databases? Remember, complexity often scales much faster than the cost savings when you move towards more intricate shared models. Don't bite off more than you can chew operationally.
Good advice. And finally, number 4.
Growth potential. Think about the future. If you start with a simple multi-tenant model for cost reasons today, what happens when you land that massive enterprise client who demands a dedicated environment tomorrow? Is migration feasible? How will your costs and complexity scale as you add more tenants? Plan for growth.
That brings up a really important point. Vendor lock-in. Even if these aren't technically permanent decisions, getting locked into the wrong model early on must be a huge pain.
It absolutely is. Migrating a mature application and its customers between these models, say from multi-tenant to single-tenant or vice versa, is a massive undertaking. It's technically complex, risky, and expensive.
So having a migration strategy, or at least understanding the potential path, is crucial upfront.
Definitely. You want to avoid getting mired in tenant limbo, as someone once called it, where the cost and risk of changing are so high you're just stuck with a suboptimal architecture. Choose what works now, but have an eye on the future, and don't let fear of change paralyze you into inaction either.
Right, find that balance. Okay, so the big takeaway here seems to be multi-tenancy is fundamentally this balancing act. You're constantly trading off isolation versus cost versus operational complexity, and the right answer isn't universal. It depends entirely on your specific situation, your compliance needs, how price-sensitive your customers are, your performance requirements, and your team's ability to manage it all.
Couldn't have said it better myself. And maybe here's a final thought for you, the listener, to take away and ponder. Think about those big, heavily regulated industries: finance, government, healthcare. How do they decide? which specific parts of their operations absolutely must run in a single-tenant, highly isolated environment, maybe core transaction processing or classified data analysis,
Logic.
versus the other, less critical parts, maybe internal collaboration tools or development environments, or initial data ingestion pipelines that they could potentially move to a hybrid or even a standard multi-tenant model to realize significant cost savings without compromising their core security posture. How granular do they get in dissecting their own architecture to optimize both safety and efficiency?
That's a great question. It forces you to think component by component, risk by risk.
Requires.
A really deep understanding.
It does.
Well, this has been incredibly insightful. Thank you for guiding us through this complex landscape of tenancy models and software architecture.
My pleasure. Always fascinating stuff. We'll catch you next time.